Hello, you are welcome to this class. In my class today, I shall be taking us on calculations that involves equilibrium constant of a reaction or equilibrium calculations. Now, if we look at the board, you see a question that says the reaction 2A gas plus B gas to give 2C gas, the change in enthalpy is plus 10 kilojoules, attains equilibrium at 300 degrees Celsius in 3 dm cubes box. If the moles of the reactant and the product present at equilibrium are 3 moles of A, 2 moles of B, and 4 moles of C, calculate the value of the equilibrium constant. Now, what we have is what? 2A reacting with what? B, all gases, okay? To give us what? To give us a 2C, also gas. Now, if you look at this, we are looking for the equilibrium constant. We know that what? Equilibrium constant, okay, which is a Kc, concentration equilibrium constant for this reaction will be concentration of C raised to power 2 divided by concentration of A, then raised to power 2, okay, then multiply by concentration of B. So that is what? That is the formula. Now, what we need to get is the concentration of what? Of each of these what? Species. But let us remember that what? The concentration of A should be equals to what? Moles of A, okay, divided by what? By volume, the volume of the container, which will be what? It will be, of course, the moles of A given to us from the equation is 3 moles of A, which is 3 divided by 3. Okay, the 3 here, the volume is 3 dm cube. So what we have is what? Is a 1 mole, okay, per dm cube for A. Then the concentration of B, okay, should also be equals to the number of moles of B, which is 2. So we are having 2 divided by the volume of the container, which is 3. So this will give us 0.67 mole per dm cube us, okay. Then the concentration of C is equals to the number of moles of C, which is 4, okay, divided by the volume of the container, and that will be giving us 1.33, okay, mole per dm cube. So from here we have gotten all the concentrations. Now, since we have gotten all the concentration, we can now put the values of the concentrations here to get our answer. So the Kc will become equals to this, which is C is a 1.33, okay, all square, then divided by our A, okay, is a 1 mole, okay, all square, then multiply by our B concentration, which is what? 0.67, okay, mole per dm cube. So if we, okay, mathematically calculate this, we'll be getting 2.64 as the what? As the Kc. Thank you very much. Please do subscribe to my video and share. Welcome. In this class, we continue with calculations involving equilibrium. Now, if you look at the board, we are given a question to find the concentration of each of the species that is present at equilibrium. It says 1 mole of hydrogen and 2 moles of iodine are introduced into a 1 dm cube box at a temperature of 490 degrees Celsius. What will be the final concentrations in the box at equilibrium? We are given the equilibrium constant to be 45.9. Now, if we want to solve this, we have a hydrogen, okay, gas reacting with a iodine gas to give us a hydrogen iodide gas. Now, when we look at this, we find out that what? That we can actually get the equilibrium constant of the reaction, or we can actually get the concentrations of each of the species at equilibrium. Now, what happens is this: if we want to get this, we need to get first of all the concentrations at equilibrium before we can get the amount that is present at equilibrium. Now, for this, according to the equation, for the start, that is at the beginning, we were told that we introduce 1 mole of hydrogen, 2 moles of what? Of iodine at the beginning. No amount of hydrogen iodide was introduced, so it becomes 0. Now, used, what is the amount of hydrogen that was used? It was not given to us in the equation. Neither do they give us any amount of the reactant that was used. That is to say, we can assume that the amount of reactant, say hydrogen, that was used is what? Is X. So if you can see that what? The stoichiometric coefficient of hydrogen is 1 and the use is what? X. It simply means that the stoichiometric coefficient of iodine, which is also 1, the amount used should also be what? X. 1 here gives S, then 1 here also takes X. Then we are talking about used. No product is what? Is used during reaction. So the amount of product used is 0. Now, what is the amount that is what? Formed. Now, no reactant is formed. So during formation, reactant becomes 0 and 0. What is the product formed? The product form can be obtained from also the stoichiometric coefficient. Now, stoichiometric coefficient of hydrogen, S, is used. Stoichiometric coefficient of iodine, which is also 1. Then you see that what? S is used. Then when you now talk about formation, if 1 stoichiometric coefficient takes X, it means that 2 stoichiometric coefficient will form 2X. So the amount of the product that will be formed will be what? Will be 2X. Now you need to take this, very important, the amount that is left at equilibrium. Amount, okay, left at equilibrium. Or if I like, instead of amount, I can use the mole, because we are giving mole as the amount. Mole left at equilibrium will always be equals to the start, okay, minus used plus formed. That is the formula we can use. Mole left will be equals to the starting minus the used plus formed. So that is to say, if we come to hydrogen, the mole used for hydrogen here will be the start, which is 1. Okay, 1 minus what is the used is X plus what is the formed? The formed is 0. So if you see now, you can see that for hydrogen here, it is 1 minus X plus 0, which is actually 1 minus what? X. That will be the amount that is left for hydrogen. When we come to iodine, what will be the amount that is what? That is left at equilibrium for iodine? It is also what? The start, which is what? 2. Okay? 2 minus what is the used? The used for iodine is X. Okay? Plus what is the formed? The formed for iodine is what? Is 0. So you can see that it is 2 minus what? X. So for iodine, we have 2 minus what? X. Okay? Now, when we come to hydrogen iodide, now the amount that is left at equilibrium for hydrogen iodide should be the start, which is what? 0. 0. Okay? Minus what is the used? The used is also what? 0. Then plus the amount of HI formed, which is what? 2X. So what we have is what? Okay? What is we have is what? Is 2X. So we are talking about start minus used plus what? Plus formed. So what we have here is what? Is 2X. 2X. Now, if we take this, we find out that we have gotten the amount that is used at equilibrium. That is the mole that is what? Left. Sorry. The mole left at equilibrium. for hydrogen is 1 minus x. The mole left at equilibrium for iodine is this. The mole that is left at equilibrium for hydrogen iodide, it is what? 2x. Now, we are not working with mole, we are working with concentration. If we are talking about equilibrium constant, so we have to get their concentration. Now, permit me to, okay, wipe the board. If we want to get the concentration of what? Of hydrogen, okay, will be equals to the mole, okay, left at equilibrium divided by the volume. What is the mole left at equilibrium? It will be, for hydrogen, 1 minus x divided by, remember it is introduced in what? In 1 dm cube, so divided by 1. So it still remains what? 1 minus x, okay, mole per dm cube. Okay, now for iodine, we are having the mole, which is the mole left at equilibrium, which is 2 minus x divided by 1. So that should still become 2 minus x, okay, mole per dm cube. Then we'll get what? The concentration of hydrogen iodide. Concentration of hydrogen iodide at equilibrium will be equals to 2x divided by 1, and that will be 2x mole per what? Per dm cube. So we have gotten the concentrations at equilibrium. If we have gotten the concentrations at equilibrium, then it is easy for us to get the what? The amount of each of them that is present at equilibrium. We can get the concentration present at equilibrium. Now the concentration of hydrogen at equilibrium should be this. Concentration of iodine should be this, while the concentration of hydrogen iodide left at equilibrium should be this. But we have to know what x is if we should know the real value. So having taken this, Kc we know is equals to concentration of, remember our equation is H2 plus I2, okay, to give us what? 2Hi. Okay, that is to say that what? Our Kc will become concentration of Hi raised to power what? 2 divided by concentration of what? H2 into what? Concentration of what? Of I2. Now let us put these concentrations and also put the value of our equilibrium constant and see what we can get. Now if we do that, we'll find out that our Kc will become equals to concentration of Hi at equilibrium. What is it? Is 2x. So we are having 2x all raised per what? 2 divided by the concentration of hydrogen at equilibrium is given to be what? Is given to be 1 minus x, okay? Then the concentration of iodine at equilibrium is 2 minus x. Now, if we multiply out, remember our Kc, which is equilibrium constant, given to us is 45.9. Now, having taken this, let us multiply out. If we multiply this thing out mathematically, we should be getting 41.9x squared, okay, minus 137.7x, okay, then plus we have a 91.8, all equals to what? 0. If we use minus b plus or minus b squared minus 4ac, okay, divided by 2a, we'll be having that our x will be equals to what? Our x becomes equals to 0.93 or 2.36. So this will be our x. Remember, x is the amount that is what used. Now, but we will not accept this value. Why? Because it is bigger than the starting material. Remember, the starting material is 1 for hydrogen. So it's bigger than 1 for hydrogen. So we accept this. So having accepted this, we can now see that the concentration of hydrogen at equilibrium, which is equals to 1 minus what? X, will be exactly equals to 1 minus x, which is 0.93. Okay? And that will give us for hydrogen 0.07, okay, mole. Okay. okay, yes, 0.07 mole, okay, per dm cube. Then the concentration of iodine, okay, which is equals to 2 minus x, will become 2 minus 0.93, and that will be giving us 1.07 mole per dm cube. Then the concentration of hydrogen iodide, okay, at equilibrium, we got it as 2x, which is equals to 2 multiplied by 0.93, because our x is 0.93. That will give us what? 1.86 mole per dm cube. So these are the what? The concentrations of each of the what species at equilibrium. Practice with this. Subscribe to my video, share and like. Thank you very much. Hello, you are welcome to this class. We want to take the third question on calculations involving chemical equilibrium. We see a question on the board. 1 mole of ethanol and 1 mole of ethanoic acid were reacted in 1 dm cube box at equilibrium. Okay, only 1/4 mole of acetic acid remained. Calculate the what? The equilibrium constant of the reaction. They were reacted in what? In 1 dm cube. 1 dm cube box. Okay, in 1 dm cube box. Now, if we want to go by this, we start by saying that the starting material that was given to us is, okay, 1 mole of ethanol reacted with what? 1 mole of ethanoic acid. So at the beginning of the reaction, 1 mole of air and 1 mole of air was what? Was introduced into the box. No product was what? Was introduced. So we take them to the 0. Then what is the amount that is used? If the amount that was used was not given to us for any of them, or, okay, is not given to us, but we know that what? We can take the amount used for ethanol to be x. That is 1 mole. We take x. That means 1 mole of this, we also take what? X. Used, no product is what? Is used. So take it to be 0, 0. Then formed, what will be the amount that is formed? The amount formed for reactant, no reactant is formed. Reactants are used. Then what is the product that is what? That is formed? 1 mole of this is used, so 1 mole of this will be formed. If 1 mole of this used is x, then 1 mole of this formed should also be what? X. So here we have x and x. 1 mole that is used is x, 1 mole used is x, 1 mole formed should also be x, and 1 mole formed shall also be what? Should also be x. But remember from the equation, they say that what? Only 1/4 mole of acetic acid remained at equilibrium. Only 1/4 mole. So amount remained was given to us to be what? 1/4. If the amount to remain is 1/4, it simply means that what? Amount used should be equals to 1 minus 1/4. So 1 minus 1/4 will give me 3/4. So the 3/4 is the amount that will be what? That will be used. Now, the amount used is 3/4. And remember here, amount used is what? X. What does it mean? It simply means that x is actually what? 3/4. Amount used is 1 minus 1/4, which is 3/4. So that means that x is equals to what? 3/4. Now, having taken this, how do we get the equilibrium constant? We are looking for the equilibrium constant of the reaction. But we need to understand the concentration of this conc of C2H5OH will be equals to, remember, the amount that is left here should be equals to the concentration, because the volume is 1. So the amount is equals to concentration. So, but what is the amount? it is what? Start minus use plus form. That will be equals to 1 minus x. Okay? Then for ethanoic acid, COOH, it will be equals to what? 1 minus x plus 0. That is 1 minus x. But remember that our x is what? 3 over 4. So this will be equals to 1 minus 3 over 4, which is 1 over 4. This one is also 1 minus x. X is 3 over 4. 1 minus 3 over 4, which is equals to what? 1 over 4. Then what is the concentration of CH3COO C2H5? That is ethyl ethanoate. What is the concentration? The concentration here, you know, for products, we should not be doing start minus use plus this. If not, it will give us negative. Because here, if we do 0 minus, okay, the use 0 plus form x, we'll be having 0 minus x, which is minus x. We don't use what? Negative. So for a product, it should be what? Formed plus what? Plus used minus start. So it should change the other way around for product to avoid negative. So it is this plus this, which is x, minus 0. And so that will give us what? X. This plus this is what? X. X minus 0 is x. And x has been already obtained. X to be what? 3 over 4. Then the same thing goes with water vapor. The water vapor there, water vapor as a gas will be equals to also x, which is equals to 3 over 4. So in general, we can see that what the concentration of this reaction, Kc, will be equals to concentration of the product CH3 COO C2H5, concentration multiplied by concentration of water, the product, divided by concentration of the reactant, which is what? The ethanol. Okay, the concentration multiplied by the ethanoic acid concentration. Okay, and that will give us this, which is 3 over 4 multiplied by 3 over 4. Then everything divided by 1 over 4 times 1 over 4. So if we do that, we'll get what? We'll get 9 as the concentration. Thank you very much. Do subscribe and share this video.